Thank you, everyone. Good afternoon, and it's nice to see you, everyone, here. So, in the theme of the event, we, as a company, we were working on most of the different areas, actually. So, one of the core area is digital factory, and as well as the intelligent factory. So, Byte Factory is our core product that we are focusing on putting industry 4.0 for all the manufacturing community. And in continuation with that, when we explore, so industry 4.0, there are different levels of maturity in the same scenario. It also involves multiple levels of technologies. So in that aspect, when we started working, we believe that AI is very key part of our strategy, and to grow our products with AI inbuilt is much needed for us as well as and for all our customers. So in that aspect, we started this particular intelligent factory division. And so the topic we would like to show is what is the role of AI in manufacturing and our latest few use cases in this as well. So if you see, there are actually many sectors that make use of AI. AI is very widely used nowadays, and it is like you have here a lot of buzz about it, and specifically in this field of manufacturing, if you say energy and mining and manufacturing, it is as well used. And in manufacturing, there are as well many use cases that are possible, right from the different sections of the companies and the manufacturers. And with respect to Byte Factory, so Byte Factory in a current context, we are positioned on delivering solutions on machine learning, natural language processing, and also like on chatbots and the perspective, and on contextual analytics and autonomous systems and image and pattern recognitions for our customers. So in this depth of solutions, we are working, all are creating our AI products. And when we go and talk about AI, I want to give you a brief on the levels of AI. So the first level is automation, where there is no need of human presence, but we are doing just automating certain tasks. This can be like, for example, we do it in most of our products. Like one example is creation of automatic tickets. So if there is a fall in, if they say the temperature falls below a certain threshold, the system creates automatic tickets, sends across mail. It is a basic level the first level of automation. And the second level is like having like the assisted intelligence, when we have kind of a chatbot or kind of a generative AI that links to our data, and it can answer our queries, or it can even do some basic level of operations with it. And third is augmented intelligence, where it is like an adaptive system which learns from the past experiences. In the same example of chatbot, if the chatbot can get the user experience and improve its response over the period of time, that's an example. Another is a predictive maintenance, which we'll talk in detail in the coming slides. And last is autonomous intelligence. So when we are having most of the speakers talk about the different levels of maturity, and the topmost is having a self-adaptive systems for Industry 4.0. So in that aspect, so autonomous intelligence is having a system that can self-correct itself, and it can operate and benefit the more factory in a very tight situation. So for example, most of our robots are like of autonomous intelligence, and as well as you have systems developed for like a paint booth that can self-correct based on operating conditions, a system that can do correction in the job orders based on the actual happenings. It can all be like autonomous intelligence. So in the top 10 use cases, we have identified like the predictive maintenance is the main, quality with vision and other things, and manufacturing process optimization. And there are a lot of use cases that are listed, and based on that, and also listening to our customer needs, we are focusing on working on some interesting use cases. And like all these reports, since predictive maintenance is the key area, so we focused on predictive maintenance, mainly harnessing the power of AI for zero downtime. So our solution comprises not only of the software or the AI part, so we are like an end-to-end provider. We provide the hardware, we provide the integration, we provide the data collection, and as well as on configuration and AI prediction for that. So the main thing is detecting anomalies. So anomalies is like just simply whether a machine or a particular process is deviating from its usual way of doing, and next having these anomalies to create triggers, and then predict the failure of components and also calculate the remaining useful life. And with this, focus on forecasting the spare parts requirement for the maintenance, and if you are having multiple assets in your factory, having like creating the scorecard and benchmarking for the asset health status. So we did this, and we are doing it for one of our key customers in India. So wherein the data is almost collected for 4+ years now for their factory. If you see with respect to Industry 4.0, we are collecting huge amounts of data. This data is lying idle if you are not processing. If you are simply having a real-time dashboards and diagnostic alerts, this data will not be used at all. So it is imperative that we are using AI for processing this data. So one such customer, we had huge level of condition monitoring data. So in their equipment, where they have these particular, this equipment, it's like an utility machine. In this utility machine, they were basic levels of condition monitoring data. We added some sensors with respect to vibration and adding something to do with the dew point, measurement, flow level, etc. And started collecting this temperature, started collecting these values. And with these values, what we were able to do is, as a first level, we were able to do a real-time diagnostics, which is the basic level. Then we were able to create tickets, like this is all in the level 1. And the next step, we were able to identify the anomalies, and we were able to predict the failures, and we were able to identify the hidden patterns among the different types of data that is there using the different prediction algorithms. And then we were able to also calculate the remaining useful life of the components, and then focus on creating the corrective actions for the entire mission. So we are currently working with them to build like an automated RCA Kappa system that can tell like if there is a failure on the equipment, the system can identify what kind of failure, what kind of solution needs to be done based on the extensive knowledge that is there. And this is one of the solutions that we have done. And next is Adam. So Adam is like our the major it's the chatbot that we have integrated. So when we have a static dashboards, it is kind of very difficult for us to understand the data, and also we are seeing a constant data, and we may not be knowing what is the most pressing issue at this moment. So for example, an operator might require something urgently, and like say he wants to know what machine is not running or what machine has a low OEE and which machine is behind the target, etc. So going to a dashboard, navigating through different machines is time consuming, and so for that we had developed Adam. So Adam, it sits on top of our Byte Factory platform, where it actually is like a NLP based system solution where we can ask questions directly on the data that is there, and it can publish the real-time information for him. So we can ask what is the production volume. So the different people and different personas have different requirements, and it's all going to that. In an extent, in this context, we are even building our Byte Factory to be contextual in nature. So when there is a home page, the data that is most pressing for at that point of time. So what is going good, what is not going good, and what is the status of, what are the tickets that are going to expire, all that data will come as part of the home dashboard. So all these are powered by Adam, and it's contextual based analytics. And the next is with our partner with Document 360. We have created the NLP for NLP based chatbot, I would say assistant, which like a chat GPT on the technical manufacturing data. So when I visited say 3 or 4 years before to a manufacturing customer who are manufacturing material handling equipment, their biggest challenge was the huge amount of knowledge that is there with people who are experienced. But this knowledge is not getting transferred to the people who are joining new, and it is also very difficult to motivate the young people to stay long in the job, and people keep on shifting in a very short span of time. So finding right resource and then skilling is very difficult. In that aspect, having a knowledge management is very informative for them, and having a huge knowledge management is kind of like in manuals and PDFs. It will be time consuming, and at the time of pressing requirement there might be some question that needs to be answered, like for example how to check for the oil leakage, or we want to know which equipment is supposed to forward. Our tool AD along with our Adam, it can walk through huge amount of text data. It can walk through the videos and analyze it, and it can give insights based on the required information. And lastly, the roadmap for Byte Factory AI. So we are focusing on high value use cases, and especially we'll continue in discussion. We'll continue with our focus on our customers, and because we have, with our 8+ years of experience, we have large amount of data that is residing with lots of our customers. We are constantly putting cutting-edge technologies to build new use cases, and we want to have all these AI systems to integrate with existing systems seamlessly, and the most is to generate value and outcome for all our customers. And final thing is like to have like a driver of closed loop systems and a self-automating systems in terms of Industry 4.0 for manufacturing enterprises. So as the theme, we would like to say there is a separate session on what we offer on sustainability, but most of our solutions that we deliver, we focus on the sustainability and the SDG goals, and how we can contribute to the SDG goals of directly or also for our customers with our solutions. So with respect to AI and Byte Factory, like we highlighted here, good health and well-being, clean water and sanitation. It's primarily with our solutions we are able to achieve all these for our customers. So we are happy to have the live demonstration of Adam as well as the AD in our booths. You can come and visit and have a detailed discussion on that. So thank you. If you have any questions, you can let me.
My name is Shilin. I am from Adi Kalloteva company. I have a question regarding the AI, which you are speaking in this session. It was very nice. Do you have any proven case of machine learning and optimization of the machine through the algorithm or machine learning?
Okay, we have proven use cases with predictive maintenance with both an SCP, that is, I'd say like a OEM companies who are manufacturing chillers, and as well as for a company for manufacturing. So wherein, when I say about the OEM companies, they were managing around 500+ chillers in their maintenance. So we connected all their equipment. With the help of, work with their R&D team, we integrated, we made predictive models and machine learning for key parameters on their equipment and also diagnostics. And we are able to predict when the chiller was going to go down and what kind of issues can happen. And also with our models, we are able to identify hidden patterns, like there are 45 parameters monitoring on the chiller, we were able to say if there's a diagnostic, which are the top 5 contributing parameters. So with that, they were able to offer like kind of a new solution to their customers to like high upkeep with the predictive maintenance. That is one use case. And now we are working with all our manufacturing customers with enabling predictive maintenance and also enabling AI with respect to machine learning for condition monitoring. Energy forecasting is another use case that we did, where we can energy analysis and helping to make them reduce the energy consumption. So these are some of the use cases that we have already done and proven.
And second part of my question is that is there any proven case that machine itself is taking the decision and optimizing its factors, its parameters, or the conditions through the algorithm?
So we have done this. For example, take the case of all your autonomous robots that we have here. So in that scenario, all are powered by machine learning and artificial intelligence. So wherein we use the machine learning itself to, the robot takes its own decisions. So we are just giving, like for example, a start point and end point. It identifies the path, it navigates the obstacles, it reads vision data, it is all doing. But if you ask from the perspective of, like say, on a manufacturing as a whole, as a machine itself, we have the capability, but it will take time to implement in a manufacturing enterprise.
Thank you. Thank you so much.
Thank you.
You mentioned for predictive maintenance that you generated some models. What about the customer data based on which it is model generated? Do you use a customer existing data, or you need to come to the customer site, install your sensors, and build the model? So how is done practically?
For standard equipments like motors, rotors, and other things, based on the standards and also some numberings, we are able to do with already proven predicted models. But when you have some systems specifically for a whole, we have to do kind of acquire the data, and from that data we have to build a model, and it has to be constantly evolved. So it's like with respect to some standard parts, for example, say vibration, and also some kinds of motors and rotors, we have inbuilt models with us. But for as a machine as a whole, we would require a lot of data as well as some amount of failure, good condition, not good conditions for us to build these models successfully.
And how do we transfer data? By cloud, or you need to install your software on our site?
It depends upon the approach we take. There are also on-premise solutions as well as there are cloud solutions. It depends upon the IT strategy that we take and the kind of platforms and applications that we implement. So we have both on-premises as well as on cloud. So it depends upon the IT strategy we take the decision. Because predictive will require high volume servers, and it may happen that it's periodical, it may change. So accordingly, it depends on the IT strategy we support our customers.
Thank you.
Ahmed from Emirates Steel Arcan. Thank you very much for the information about the digital factory. But you mentioned that the AI can adapt to different situations without the human assistance or interfere. But this brings to my mind there is a threat also on other hand, to increase the unemployment rate. So what you suggest, or the alternative solution, how the societies or the government can face such a problem, especially for those countries who have a huge number of the manpower should be utilized? What do you think? Thank you.
Thank you. So the role of AI is not to eliminate the human. So it is primarily to help to understand data, and it is primarily to help them to grow. It is like, say, most of the automation happens on routine tasks that require high quality, and it may not require high level of skill sets that are needed. only those are getting automated, and definitely it is from the perspective of safety and also the skill level, it is not a very big challenge for them. So it's like mostly, I would say, like automation and robotics is it's responsible for upkeeping safety for the environment, and also focus on removing monotonous job nature of certain jobs. But other than that, I think most of as a whole, Industry 4.0 itself is focusing on creating more employee values in the organization.
Hello, good afternoon, Mahesh here. Just a small question to you, like how do we validate what AI is giving us a feedback? So for example, whatever, to my understanding, whatever data we feed and we configure, based on that, it gives a feedback to us.
When we do our A, for example, the same chiller predictive maintenance emission. So what happens is that the A, say if you have 40 parameters, it will be still predicting all the 40 parameters, and we will not be monitoring all the time what the prediction is, but the system will monitor what was the predicted value and what was the actual value, and it will give you the accuracy rate as part of that, and based on the accuracy rate it will keep on changing and machine learning to reach a higher accuracy rate. And if it's for a certain period of time, if the accuracy rate is not changing, it is that we have to change the model itself. And with that parameter, and we can definitely know whether the AI is performing accurately, and that itself is a measure of whether the AI is working correctly, and we can take a correct decision on that.
So what I understand is there is no chance of an error or misleading information to us.
Correct. For example, say a machine that has no failures, if you put AI into it, it will be predicting normal behavior. And if there is a failure, there will be a huge spike in the reading and abnormality, and the AI prediction will be deviating from the actuals, and then slowly machine will do a recalibration, and it will do a machine learning and build it to the correct model.
Thank you.
Thank you.
Thank you. Thanks for the presentation. I'm Kalidas from Morgan Advanced Materials. Approximately how many data points are required to build a reasonable AI decisions?
Say it depends upon the use case, but for example, say a simple vibration requires 6 to 9 parameters, and based on the configuration we are able to predict the vibration and anomalies. But for a complex scenarios, we would require a lot of points. And I would say more than the data points, I would say the quantity of data and the quality of data, as well as having a mix of the right data and bad data. I mean, bad data is the scenarios in which the machine is performing right, and scenarios in which the machine is performing not right. If these data is there in sufficient quality, we can create a successful AI model.
Yeah. What about the number of data points? Approximately how many datas required?
Generally, we would say like 3 to 6 months, but it depends, like again saying the quality of data. Say if machine does not say fail for 6 months, then we would require some more data, or we would require some historic data to be refed.
Thank you.